Thank you all for joining us for today's webcast introducing Azure Service Bus Brokered Messaging presented by Rick Garibay. My name is Amy Nelson, and I'm the Marketing Coordinator for Neudesic and the moderator for today's webcast. This webcast is presented by Rick Garibay, Neudesic's General Manager of the Connected Systems Practice. We are very excited to have him present for us this morning. If you are logged on, you should all be able to see the title slide that states Neudesic. There was a brief intro earlier regarding features within Live Meeting. To briefly recap, we encourage you to ask questions throughout the session by typing them in. To ask a question, click on the Q&A verbiage located in the toolbar on the top left side of your screen. Type your question, then click the Ask button. Please note that all questions will be held until the end. We will also be using the seating chart featured within Live Meeting. Changing your feedback color within this tool provides feedback to the presenter. To provide feedback, click on the feedback menu found in the upper right-hand corner of your screen. Select your feedback color. Your seat in the conference center will display your selected color. Lastly, this webcast is being recorded and will be available via the Neudesic website. We will email you when the link is available. If everyone is ready, please make sure your seat color is green. At this time, I'd like to turn our presentation over to Rick.
Thank you, Amy. Good morning, everyone. It's my pleasure to be with you here this morning as we take a look at some of the newest innovations and features that have been released with Azure Service Bus, including brokered messaging. Before we begin, I want to start by just doing a quick poll around the level of understanding around the holistic service bus capabilities. So Amy's been kind enough to prepare a couple of polling questions. Amy, would you mind walking us through those?
Of course. First question. Have you worked with Azure Service Bus Relay capabilities before? Yes or no?
So really looking to understand what your level of comfort is with the relay capabilities, which will kind of help me adjust how much time I spend on Azure Service Bus Relay. Give it a few more moments. So it looks like the vast majority of attendees is already very familiar with Azure Service Bus Relay, so I will just touch on that. And I think we have a next question as well.
Yep.
Which is on a scale of 1 to 5. How familiar are you with actually working hands-on with relay capabilities? So the previous question was, familiarity, understanding. This is really kind of hands-on. You play with the bits. You understand kind of how to take advantage of relay. Okay, so about 50-50 on that one. So I'm going to assume that the majority of attendees are familiar with relay. About 50% of attendees have actually written code that actually takes advantage of relay capabilities using the relay bindings, and that definitely helps a lot. So I'm going to go ahead and get started then. I appreciate everybody's feedback. So by way of introduction, as Amy mentioned, I am the general manager for the Connected Systems practice at Neudesic. I own the strategy and execution for Neudesic's integration middleware strategy. So we focus on everything from BizTalk Server to Windows Server AppFabric on-premise, Azure Service Bus, Access Control service in Windows Azure, WCF, workflow, anything that kind of is within the messaging service-oriented domain is kind of what we do. I'm a 5-time Microsoft MVP for Connected Systems, as well as a Microsoft Connected Technology Advisor, which is an advisory role working directly with the product groups at Microsoft to provide feedback and assist in product planning. And I run the Phoenix Connected Systems user group. I'm also the co-founder of the PCSUG, in Phoenix, obviously. We meet the first Wednesday of every month at the Microsoft Southwest District Office. And if you're attending in Phoenix or might be visiting in Phoenix, we would love to have you. So pcsug.org is a good landing place to learn more about the user group. You can always catch up with me on Twitter as well as on my blog. And definitely look forward to continuing the conversation. If you have any follow-up questions, thoughts, comments, by all means do follow up with me, and we'll make the deck and the samples that I'll go through from a code perspective available after this webcast. So at Neudesic, we've been doing a ton of work over the last year and a half around hybrid composition solutions. And basically what that means is today is companies of all sizes are really trying to rationalize cloud. What the opportunity really is today is to look at what are some of the assets on premise that exist today, or new opportunities that maybe the expense and the procurement on premise precludes, to really taking advantage of cloud computing. And so what we do is we work with customers who want to, first of all, identify what some of those workloads might be, or maybe already have a good idea. And we really look at the platform of capabilities that is available to us. When you think about where we are today from a Microsoft platform perspective, there really has never been a more exciting time to really take advantage of all the capabilities that the platform has to offer. Whether that means that you're doing traditional enterprise application integration or messaging where durability and guaranteed message delivery is absolutely critical, this top server provides a number of capabilities, along with rich vertical integration for tackling some of the toughest integration chores. And on the other hand, if you want to do lightweight messaging, want to take advantage of the hosting, monitoring, and caching capabilities that are now available at the platform level, Windows Server AppFabric provides a number of capabilities that complement BizTalk. Neudesic in 2005 actually released a product called Neuron ESB. And the whole idea behind Neuron ESB is to basically build on top of WCF and make it very simple to take advantage of lightweight pub/sub messaging. So where you're looking for low latency, high throughput, and a really short learning curve, Neuron ESB is a great fit for filling those capabilities out within the platform. And as we've evolved, what we're seeing, right, is that more and more customers are looking at what are the right assets to move into Windows Azure. And the linchpin to our hybrid strategy is Azure Service Bus. And Azure Service Bus isn't new. It's a technology that's been around now for a couple of years. But what we're seeing is the maturity of the capabilities provided by Azure Service Bus, and we consider an absolutely critical component as part of our platform strategy, and working with customers every single day that want to make sure that when they take advantage of the scalability, the cost benefits of the cloud, particularly Windows Azure, that they're not doing so at the expense of the integration and connectivity that they have today. So at Neudesic, we look at Azure Service Bus as a key enabler to making sure that integration becomes first class and continues to be first class, regardless of whether your assets are being composed on-premise or in the cloud or other partner clouds. So with that, today I'm very excited to talk about some of the new capabilities that have recently been released, highly anticipated capabilities around brokered messaging, which really complements relayed messaging in Azure Service Bus. So what I want to do is start by talking about publish, subscribe, and just kind of set the stage for why we think pub/sub is important, and why you should consider pub/sub as part of your distributed solution design and architecture. We'll talk about Azure Service Bus, what it is. We'll do a very quick review of relayed messaging, since it looks like the vast majority of attendees are pretty familiar with relayed messaging. And then we're going to actually spend the most of our time talking about the brokered messaging capabilities. We'll look at the 3 different APIs available for taking advantage of brokered messaging, meaning queues, topics, subscriptions, rules, including the .NET Client API, the REST API, and then a new binding that's available to WCF developers called Net Messaging Binding. And For those of you that have hands-on experience with relay messaging, you'll find a very familiar model for taking advantage of queues and topics via the WCF programming model within that messaging binding. And as Amy mentioned, any questions, feel free to queue them up along the way, or if you want to hold them until the end, that's fine. We'll definitely take some time at the end here to answer any questions you have, and I'll be happy to hang out as long as attendees would like to. So with that, let's go ahead and get started. So why publish subscribe? So first of all, publish subscribe is really a design pattern for loosely coupling a client and a service, or a publisher and a subscriber, such that when you have a single publisher and subscriber, which is the case for many point-to-point applications, it's actually not too complex, right? You have a single endpoint, maybe you have a couple of endpoints, and you can manage those accordingly. Where things start to get a little more complicated, and where pub-sub as a pattern really becomes very interesting, is when you start to think about the different activities or the different things that happen within an application as events. So a canonical example that we can talk about is a point-of-sale system. And in a point-of-sale system, if you think about either a brick-and-mortar point-of-sale system, or maybe an e-commerce type of application, you have some kind of a client that interfaces with either customers directly, or maybe there's an inbound customer service agent that's managing orders. And then there's a number of different things that happen. First and foremost, there's the exchange of financial information once the consumer has identified what items they want to purchase. And once that happens, there's basically an event that is very interesting to downstream functions within the organization that are interested in making that sale, right? So first of all, you need to make sure that the item is available. That's kind of one of the first things that you probably want to check. Then you want to look at the credit authorization and make sure that the consumer has funding to actually pay for this. And then somehow you have to ship that widget, that product, that has been purchased and get it to the consumer. Now, what's really interesting is that when you think about these steps in the process, you can kind of think of it as a business process, right? You can think of it as this composable unit of work where there's coordination that's happening along the way, but you don't want that coordination to be owned by the point-of-sale client, right? Because now you're basically coupling a lot of different concerns to the point-of-sale client, which, after all, its job is just basically to get as many purchase orders through the system as possible. So pub-sub becomes very interesting in this notion of a purchase order event or a purchase event, and then looking at what other downstream services or applications, such as the credit service, the inventory service, and the fulfillment service, might be interested in that. So definitely encourage the use of pub-sub as a way to decouple your clients and services. There's a saying that I like very much that's friends don't let friends do point-to-point, and I believe in that. So highly encourage you to take a look at pub-sub along with other patterns for really gaining the most agility in your distributed solution design. So with that said, let's talk about Azure Service Bus very quickly and what it is. One of the key capabilities that Azure Service Bus provides is the ability to transcend traditional trust boundaries. And so what I mean by that is, if you think about the way that we've been doing service composition for the last decade or so, you have this notion of an endpoint that's hosted in some expensive infrastructure somewhere, whether that's at your own company, organization, or some provider that makes sure that's accessible over the internet. And we happily send a message from the client to the service, and we're able to either get a response back, or maybe it's a one-way message. And there's really nothing that interesting about that. One of the challenges or impediments that we've had for the last decade or so is actually reversing those two roles, right? So for the service, or for a client behind that service boundary, behind that data center, to actually be able to reverse that and make a call back into an application behind your firewall, behind your trust boundary, very, very difficult. And there's good reason for that, right? We've actually learned that there's a number of really bad guys out there on the internet. And the challenge becomes, how do we truly elevate services and this composition model such that we can truly deliver on the software plus services promise while making sure that we keep the bad guys out and let the good guys in. So when you think about why that reverse message exchange doesn't work, is that there's a number of different things like network address translation, where we run out of IP addresses, right? So everybody has typically a internal IP address that gets you onto the internet. Then you have typically a network firewall, regardless of where you work. And then most modern operating systems, client and server, have a software firewall. So this is a challenge for us, right? And truly taking advantage of software plus services, especially when you think about starting to move these assets to the cloud and having a messaging strategy for making sure that you can still call back into your assets on-premise, having moved those workloads into the cloud. So when you think about typical ESB or enterprise service bus capabilities, really we talk about pub-sub. And pub-sub is one of those core design patterns that the whole role of an ESB is to really commoditize, right? So if anybody that's in attendance has ever, hand-rolled, a pub-sub implementation, it's certainly not impossible, right? You can do so with WCF and .NET and other tools, but it's not the cleanest or the funnest thing, and it certainly isn't easy to implement a highly maintainable and manageable approach to doing pub-sub. And so most service buses, most enterprise service buses, at their core, provide this messaging fabric that includes commoditized support for pub-sub, for things like message transformation, routing, the ability to encode, decode messages as they enter and exit the messaging fabric. And so, when you think about those capabilities, it's usually the messaging piece, which is kind of the core of the messaging infrastructure. Then you certainly need to have a repository for quickly and easily finding and managing the services that are available. And then there's obviously some cross-cutting concerns like security and monitoring that are critical to making sure that only authorized clients or consumers are actually on-ramping and off-ramping the bus. And so when you think about pub-sub and you think about this kind of location transparent approach, the whole idea is that you can think about these endpoints that are hanging off of the bus that are consumed by a client, and that client then, in the scenario where we're thinking about an inventory service, a credit card service, a fulfillment service, really never knows what those endpoints are, where they are, what they look like, right? His job is purely to publish a message onto a specified endpoint signaling a purchase order event, and now the bus infrastructure is responsible for routing that accordingly. So AppFabric Service Bus or Azure Service Bus is really all about taking some of those key capabilities and basically projecting them into four main categories. The first is a naming fabric, followed by a service registry, and then the messaging fabric is really what makes it all very interesting. Obviously, when you're talking about using Service Bus to compose your assets both on-premise and beyond, security is a very deep concern, and Azure Service Bus addresses that by complementing the Service Bus capabilities with the access control service, which makes sure that you only are authorizing individuals that you actually want to give permission to on-ramp and off-ramp your bus. So I'm going to skip through a couple of these since there was a lot of experience with this in the call, and just touch a little bit on relay messaging. So with relay messaging, which really provides that ability to traverse these traditional network and trust boundaries, there's a number of different WCF bindings that are available. All but two of them complement their non-service bus relay equivalents, right? So if you want to do, SOAP messaging that's compliant with the WSI basic profile, you can use the basic HTTP relay binding. If you're building REST services, you can leverage the web HTTP relay binding. The NetTCP relay binding is the counterpart to the TCP or the NetTCP binding within WCF, and it's actually the binding that we recommend because it provides a number of capabilities, including the ability to upgrade a connection, support for load balancing, high availability, etc. And then there's two bindings that actually don't have a traditional WCF equivalent, and that's the NetOneWayRelayBinding, which is an optimized binding for doing one-way or datagram messaging over the messaging fabric. And then there's the net event relay binding, which is all about basically doing multicast over two or more different parties or endpoints that might be interested in receiving the message. So as kind of a recap, the way that the service bus relay capabilities work is, if you think about this messaging fabric as really this collection of infrastructure that is hosted on Azure itself. Basically, the way that this works is that a service that on-ramps the service bus using one of the bindings that we just talked about actually creates an outbound connection on port 828. And that connection is actually bidirectional, which is kind of a little bit of protocol magic happening behind the scenes. And the client will actually also connect over port 828. And then the messaging that takes place between the client and the service is now basically being mediated by this messaging fabric, which actually makes it possible for the client and the service to communicate regardless of where they are in the world, provided they have an internet connection. Now, one of the things that's important to note is that when you think about the firewall implications of relay binding, one of the things to consider is that the technology here is really no different than traditional client server chat applications, right? So if you've been using, Yahoo Messenger or Windows Live Messenger, it's really literally the same technology, the same capabilities that are at play. And again, what makes this really interesting is that it's typically very difficult to convince anybody within most organizations to open up inbound ports, right? Which is kind of one of the main value propositions of relay messaging. It's equally challenging in some cases to look at all the different ports that are available and kind of do that port math. So chances are that with the exception of really severely locked down environments, outbound ports tend to be open. And in the case where that's not the case, NetTCP relay binding provides the ability to actually use HTTP as a fallback, which is another good reason to look at that as a potential binding. So with that said, we're going to go ahead and jump now into brokered messaging, given that recap. So we talked about publish subscribe as this pattern and the utility of that. And when you think about relay capabilities within Service Bus, relay is very much a push model, right? I send a message from a client through the service bus to an endpoint. The endpoint's listening, and when an event happens that's of interest, provided he's listening on that namespace, he receives the message without really having to do anything more than just sit there and listen. And push pub sub is a great model that applies to a number of different scenarios, but sometimes where durability, guaranteed message delivery is important, or you want to be able to scale across a number of different load profiles, or in some cases actually provide a very performant throughput, queues have been a proven approach for actually managing a lot of those different considerations. So the idea with the queue is if you put a queue in between our point of sale client instead of the inventory service, the whole idea here now is that the point of sale client really doesn't care that the inventory service is up or down, and is simply just writing purchase order messages, these units of work, to a queue, which the inventory service can go ahead and consume when it's available at its pace, which actually provides a pretty good approach for doing load leveling. So if you think about the scenario where maybe the inventory service is down, rather than the point of sale client stop actually processing orders, these messages or work items can queue up until the actual service is available to start consuming those units of work and doing the appropriate lookups. And this might seem a little bit strange to you in the example of a purchase order, but I would actually challenge you to think about some of the larger e-commerce or e-retailers that you might do business with today. And if you're like me, there's probably been a handful of occasions where I've gone on to the website, I pick my items, I check out, which is very expedient, and then I get an email maybe a couple hours later saying apologies. Turns out that the item is not available. We haven't charged your credit card. Or how many times have you gotten an email indicating that whoops, your credit card's expired? Please log in to the website, update your credit card information, and we'll be happy to continue processing your order. And that's actually good for business, right? So this temporal decoupling is actually good for business because the whole idea of any of these front-end retailers on the web is to actually make the experience for checking out as seamless as possible, right? And so imagine if you were sitting there waiting, blocking for the inventory service to be called, the credit card service. It really is kind of an impediment, and any more than 3 or 4 seconds, it's been proven that as consumers, as users of software, we start to perceive performance issues. So the whole idea here is get the order done as quickly as possible, do some processing asynchronously, and queues absolutely are at play in many of these different scenarios. Might not be Azure Service Bus queues, but queues as a pattern is absolutely very prevalent in these types of environments. One of the things I mentioned is the potential performance advantages of using queues. So if you think about the publisher writing messages as quickly as it can write them to a queue, you can have a number of different workers or consumers of these messages, right? And you can actually throttle the amount of work that they're able to eat based on the resources and their capabilities, such that you can have some consumers that are, beefy instances, others that might not be. You can spin consumers up to adjust for these invariant loads, and the result of that can be an actually pretty performant system. So competing consumer as a pattern is one that is afforded by queues, and this has nothing to do with Azure Service Bus right now, right? This is a universal understanding of some of the capabilities and potential that the queues provide. Topics are kind of interesting, right? So topics are really nothing new. They've been a mainstay of JMS-based development for quite some time. And as with queues, Azure Service Bus actually has support for topics as well. And the whole idea with the topic is the store, if you will, is still very much a queue. It has all the capabilities that a queue provides. But what it actually does is, as opposed to having a one-to-one relationship, if you will, between the producer and the consumer, now we have a one-to-many relationship where the interface between a party or a consumer, such as the credit service, the inventory service, the fulfillment service, is actually a subscription. And so in this model, these parties or these subscribers will actually never read directly from the queue or from the topic, but instead they actually consume messages based off of a subscription. And what a subscription allows us to do is logically partition the types of messages that are of interest to the different subscribers. And we do that in Azure Service Bus by using rules, which I'll demonstrate here shortly. And so the idea here is you can imagine that, if you've ever noticed that sometimes when you place an order, depending on where you live, the order arrives much quicker than other areas. And one of the reasons for that is that, smart retailers actually have distribution and fulfillment centers that are geographically located, right? So there's a DVD rental service that I use that, being in Phoenix, I can place a movie on my queue on a Wednesday, and sometimes I get it Thursday afternoon, often no later than Friday, right? And so it turns out that there's a distribution center that actually serves Arizona, California, and other states, which is actually pretty nice from a customer experience perspective. And so when you think about that, a fulfillment service for, say, the eastern region versus the western region actually is only going to be interested in orders that correspond to customers living in those different geographies, right? And so we'll actually show an example of that where I have 2 fulfillment centers, one covering the Americas, one covering Asia, and we'll actually look at how that would be implemented with topics. So topics are very similar to queues, but they add a number of different capabilities that allow you to partition those messages across different party or different subscribers, and kind of is a step up in terms of what you can use queues for. So as I mentioned in the introduction, there's really three different ways that you can interact with these brokered messaging capabilities. So leveraging queue topics and subscriptions. The .NET Client API is the most robust. It actually allows you to do everything from all the things that you think about from an administrative context perspective. So you're setting up your queues, you're setting up your topics, you're creating them, you're creating subscriptions, filters, rules, etc. You can do all of that with a .NET Client API. The REST API is all about maximizing reach across different user experiences. So whether you're building highly cross-platform web experiences, or you're building mobile applications, the whole idea here is that if you can do outbound HTTP, you can take full advantage of queues and topics with Azure Service Bus brokered messaging. And then again, net messaging binding is the approach that the WCF developer will use. We're actually not having to get into the details and the muck of all the different things going on, and simply host an endpoint and exchange messages with that endpoint, or on the client side, taking advantage of the queue and topic capabilities accordingly. So let's take a look at some of the common types that you'll run across, particularly in the .NET Client API. First, the namespace manager is actually used in what I call the administrative or management context. And what it basically does is gives you the ability to basically create your queues, right? So you're going to create queues on your namespace, you're going to configure them, etc. There's a new message type called brokered message. This brokered message has nothing to do with the WCF channels message. This is a new message type that actually supports things like properties that we'll actually take a look at in the upcoming demo. And it's really the unit of messaging for broker messaging. Queue description merely defines a queue, and then there's a type called a message factory or messaging factory that will actually be used for both queues and topics, which is basically a factory that you ask for a queue client or a message sender and message receiver, and it provides that for you, taking care of all the runtime initialization to the actual messaging fabric. One of the things you might be wondering is, what is the difference between a queue client, which is used to send and receive messages for queues, and a message sender, message receiver? The answer is that if you want to abstract whether you're dealing with queues or topics, message sender, message receiver is a good approach for doing so. An example might be that you start off with queues. You find that actually you have different types of subscribers, and queues aren't really the right thing you're looking for, and you want to go ahead and upgrade to topics. If you're using the queue client, then you have to refactor some of your code, obviously, to take advantage of the topic client capability. Message sender, message receiver just abstracts all that for you. So definitely a nice capability if you want to kind of insulate yourself from that type of change. One of the things that's important to understand when it applies to both queues and topics is receive mode. So there's basically two types of, there's two modes available for receive. And the receive mode is all about the mode that you're using when you're actually consuming or pulling messages off the queue or off the topic. The easiest and most efficient is called receive mode read and delete. And as the enumeration type suggests, the whole idea with read and delete is you go ahead and read a message, you pop it off the queue, and the message is gone, right? Whether it succeeded from a downstream processing perspective is really secondary to, I want to be able to just pop a message off the queue as quickly and easily as possible, and it's what's known as a disruptive read. Peak lock, on the other hand, kind of follows a interesting kind of two-phase commit approach to this. With peak lock, when you use that mode, which incidentally is the default, you have a lock duration that starts counting down, and if that lock duration, say for example, is 60 seconds, which is the default, if the fabric does not receive an indication from you that you are actually able to not only read that message, but you've completed processing within 60 seconds, that message will then become available once again for processing. During that 60 seconds, however, that message is locked, and only a party with a lock ID, which is a unique identifier that represents that lock, can actually ask for that message to be unlocked. And so the approach that is recommended here is to actually call complete once you've completed processing, passing back that lock ID, which informs the fabric that you've completed the processing of that message, and it can then remove it, or put abandon, a call to abandon, in a try-catch block, such that if something goes wrong, you can actually inform the fabric that you weren't able to process it, go ahead and release it, and let some other consumer go ahead and grab that message. So receive mode is definitely something worth understanding and modeling according to your needs. So with that, let's actually jump into the demo for queues. I'm going to pull up Visual Studio here. And I've ratcheted my resolution down pretty low, so if this looks a little bit large, Fisher Pricey to you, I apologize for those of you on larger resolutions. So what I have here is basically just a console application. I have a reference to Microsoft.Service Bus. The easiest way to get your hands on the brokered messaging capabilities is by NuGet, right? So if you go and you right-click on your references and select Manage NuGet Packages, momentarily you'll get a list of packages that are available, and on Windows 7, they're actually even nice enough to list the packages that you've most recently used. So I'm going to go ahead and type in Azure Service Bus. Oh. Yeah, we meant to go down line. And what we should see here is the NuGet package for Azure Service Bus, which for whatever reason is not coming up. Well, at any rate, trust me that it's there, and I encourage you to use NuGet whenever possible. When you do add a reference to NuGet, basically it'll create a lot of the configuration for you around some of the extensions that are necessary, pointing to the version that you're using. So actually version 1.6 just came out yesterday, as a matter of fact. I was not brave enough to upgrade that for this talk, but some of the nice things that come with 1.6 is the ability to actually eliminate the need for TCP 93354 and do a direct HTTP connection, which is nice where 9354 outbound might be blocked. But at any rate, when you add the NuGet package, it basically gives you a lot of the configuration that you need to get up and running. So let's actually take a look at this. I'm going to go ahead and just quickly show you a class that I've created called Order. It's very simple. It consists of an order ID, a property called Products for storing the different products and prices, and then a field for the total. And within my program file, I basically have a number of different things going on around the administrative or management context, the runtime operations, which is basically sending and then receiving a message off the queue. And so let's go ahead and step through this to actually show you this in action. Go ahead and minimize all this stuff. Hopefully you guys can see that. In fact, what I can do here is bring it up like this. So here we have some stuff, and I'm going to trust that you're not going to steal my key. Got some fields there to just store the initial values. You'll notice this namespace manager settings, which is basically required for configuring the Azure Service Bus with the issuer key, which will then issue a token downstream, which is pretty much hidden from you, pretty nice. The namespace manager here, as we talked about, is going to be used for the administrative or management operations. So I pass it a URI to the actual service namespace that I'm using, along with the settings, which include the issuer name and key. And now I'm basically going to check to see if the queue exists. If it does exist, or if it does not exist, I'll go ahead and create it with a given lock duration, in this case being 30 seconds, so overriding the default of 60. And if it doesn't, if it already exists, then I'm just going to go ahead and keep moving right along. So I'm going to go ahead and F5 to that. So now we know that we have a queue available to us called orders, and I'm going to go ahead and create my messaging factory, passing in again the necessary issuer and key for authenticating to the ACS service. And then from there, I'm basically going to ask the messaging factory for a queue client. And the queue client, as we talked about, is the class for actually doing send and receive operations across a queue. You'll notice here I've got a regular class that is serializable. I'm setting some properties on that class. And now I'm going to go ahead and create this brokered message, passing it in the instance of the order, which it will then serialize to its body. That's really all there is to it. When I send the message will be written to the Azure Service Bus queue, and now we're actually ready to read from the actual queue. We'll just wait for that to return here momentarily. Okay, so now on the receive side, I basically want to go ahead and just call receive on the queue client. I'm expecting back a brokered message. If that brokered message isn't null, I'm going to go ahead and grab the order from the body of the brokered message and serialize it back into the received order. And now what I'm actually going to do here to show you the effect of the different modes here for receiving is actually simulate something going wrong. So if I go ahead and click F5, I'll show you here on the screen what that looks like, right? So I'm simulating an exception, and I'm going to go ahead and try to receive the message again. And this time, just to show you the simplicity in which you can alternate between queue clients and message receivers, I'm just going to use a message receiver this time. I could have just as simply used a queue client, but this is really just to show you what this looks like. Now this time, when I receive, when I go to receive the message, I'm going to actually play by the recommended rules, which is I'm going to go ahead and call receive. I'm going to grab the order out of the message broker. Obviously, there'd be some work that would happen between lines 127 and 130, and then provided that life is good, I'm going to go ahead and call complete, passing back this lock token, which uniquely identifies that lock on that message. And once I've done that, I'm going to go ahead and be done. Now, for whatever reason, any of the code within the try-catch block is problematic, then I would basically catch that exception, and I would call abandon as a courtesy to other consumers to go ahead and be able to consume that message. So go ahead and click F5 just to get through this, and you'll see here the effect of that second attempt, which should succeed within 30 seconds, which is the lock duration. So that is interesting. Let's go ahead and run this thing again. Might have been doing too much talking there. Okay, there we go. So what you can see is that the initial order of 42, we did not release the lock. Then we basically tried again, and the message wasn't available. So there must have just been something up with that second read. But as you can see, the message was read and released from the queue. Okay, so we looked at queues. Now we're going to shift our focus to topics. So with topics, there's some new types that we haven't talked about before. The topic description is basically just describing a topic. The subscription description is the same idea. It describes the subscription type. Same with rules. So rules is basically how we'll determine those filters on the message using SQL 92 syntax. And then we have the topic client that is used to publish messages onto a topic, and the subscription client, which is used to subscribe from each of the subscriptions based on the filters that match those subscriptions. Again, you can use the message receiver, message sender in lieu of the topic and subscription clients. So quickly talking on rules and actions, I mentioned that rules are expressed as SQL 92 expressions, so it provides the developer with a pretty familiar syntax for determining what messages should constitute that subscription. You can also use actions, which are optional. I'm going to show you kind of a nifty use of actions in this next demo, but you can opt to not do actions. And the whole idea with an action, though, is that if your rule basically matches a message, then you can basically fire off an action such as modifying a different property or acting on that in some way. So it's kind of you can think of it as a very kind of lightweight orchestration opportunity to do some work there. So let's actually take a look at the topic demo in action here. I'm going to go ahead and close this, and we'll go ahead and step through topic. And what you'll see is that the solution is actually very, very simple as well. I've got my order type, I've got my program, my configuration that NuGet provided, and we'll go ahead and run the topic sample. Let's see here. Let's try that one more time. That is interesting. Let's try our luck and go for it. So very familiar so far on the administrative aspect. I've got a namespace manager. My namespace manager is going to look to see if this topic name of orders topic exists. I can actually show you what that looks like within the management portal. So here I have my orders queue. I have under topics a number of different subscriptions under the orders topic. So the expectation, obviously, is that this next several lines of code actually are completely benign. And now basically what we'll do is we'll basically create these subscriptions. And a subscription basically is just a matter of naming that subscription, giving it a topic name that you're going to associate to, and then a friendly name. And so as you can see here, I can create my inventory service subscription and my credit service subscription with a line of code each. And then I'm not going to do anything special with inventory and credit. In our fictitious domain example here, we can assume that there's one inventory service, one credit service that serves the global company. But then we have two fulfillment centers, one that is focused on fulfilling orders that originate in North America, the second in Asia. And so I create a rule description, giving it a name, and then I can actually add a filter using SQL filter, which is actually one of a number of different filter types that you can use, but certainly the most powerful. And what you can see here is a very familiar SQL syntax where if the country of origin, which is actually a property that I've created on the brokered message, which I'll show you here in just a moment, is the United States, Canada, or Mexico, then we're going to actually use an action here to set a different property on the brokered message class called fulfillment region to North America. So kind of a nice example of what that action can provide. And then the same exact thing is true for the Asia Fulfillment Center, right? In this case, if the country of origin is Japan, South Korea, or Thailand, obviously not a comprehensive list by any stretch of the imagination, then the fulfillment region will be set to Asia. Once I have created those rules, I basically associate those to the actual subscriptions, and provided those subscriptions don't already exist, I can go ahead and create them. So I'm going to go ahead and advance to that. Now, after all of that heavy lifting, we're into runtime operations. Now, keep in mind that this code here, likely only gets run one time, right? And everything that I'm showing here from a topic and basic subscription perspective can all be configured within the management portal. We can actually take a look at the actual subscriptions, and you can get some metadata on those subscriptions here, and create them here if you'd like, or within code. So it's really a one-time thing, unless obviously you're going to make some changes. Okay, so now very familiar to the queue model. I'm going to ask the messaging factory for a topic client. A topic client knows how to send messages to topics. That could just as easily have used a message sender. And then everything here is actually pretty consistent with the approach that we used before, except that now I'm actually making use of the properties, the property badge available as part of the brokered message type. So I'm creating a custom property called country of origin and fulfillment region. And in this case, I've arbitrarily set the country of origin to Japan. I go ahead and send the message, and now I'm basically ready to start receiving messages off the topic. So let's actually take a look at that code. The code for receiving messages off the topic is actually very familiar, very similar to the queue code. You'll notice here that I'm actually grabbing I'm issuing a receive, getting a timeout here, and I'm going to do the same thing I did in terms of the pattern. So once I've grabbed the message, provided nothing's gone wrong, I'm going to go ahead and call complete, passing in that lock token. And then what you'll see here is that for the inventory service subscriber and the credit service subscriber, there really isn't anything special going on. But you'll recall here that because I set the country of origin to Japan, the North America fulfillment service subscriber actually is not going to have any messages, right? And the reason for that is that the filter on that is really looking for messages that originated from a country in Asia. So let's go ahead and actually run this, and I'll actually show you what that looks like. So we have no messages for North America, but sure enough, there's a order for the Asia fulfillment service subscriber, and that order is ready to now be expedited to the customer in Japan. That's really all there is to taking advantage of queues and topics with the API. And obviously, there's a ton of other stuff that you can do here, but I think you get the idea. I do want to show you, since I'm in the solution and we're kind of getting a little bit tight on time, so there's a ton of stuff to cover, the net messaging binding. So taking a WCF approach. If you're familiar with WCF, all this will look very, very familiar to you. I have a service contract called iOrder service. It basically is going to just support a one-way operation for processing an order. That order is, in this case, notice, obviously a WCF message type will be used as a WCF message. So I'm using the same data contract here. The implementation of that couldn't be simpler. I'm basically going to write to the console that the order has in fact been received. The interesting things that happen here from a versioning perspective is that, by the time that a message gets to WCF, it has in fact been converted from a brokered message to a WCF message. And likewise, if we look at my code here on the client side, I am absolutely dealing with a WCF message as part of my channel factory, and basically, Service Bus, or the binding itself, actually is doing that translation for us. So the nice thing is, as a WCF developer, this code here, which I'll just walk through very quickly, has really nothing to do with Service Bus. It's very familiar. The only thing different here, really, is that we're using a net messaging binding. And everything else is boilerplate WCF, right? I'm creating a service host, passing it a service endpoint, and listening for messages. And on the client side, right, I'm basically using a channel factory. Of course, I could use a proxy approach as well, but this is a nice kind of example all in one. I'm creating a channel factory, and I'm basically putting a message on the queue. In this case, you'll notice here that the URI is my namespace.servicebus.windows.net whack orders would work exactly the same way for topics. So very familiar programming model. And the result of that is, without knowing a lot of the different intricacies that I've just covered, you can get up and running with WCF quickly and easily. I'm going to go ahead and start this instance. We should see the host open, and it's now ready to start processing messages. The channel factory sends an order with an ID of 42 because the answer is always 42, and the order is correspondingly received. Really all there is to it, guys. So let me pop back into the deck. I'm going to wrap up with, I want to show you the REST API, and then we can basically wrap up. So real quick, so REST support obviously is what's going to be very interesting to a lot of web developers if you're doing development, outside of the kind of enterprise boundaries, if you will. Certainly doing mobility, cross-platform web development, which is very, very popular. There's a lot of things that you can do with the REST API, but it's not as comprehensive as the .NET API. And one of the things I failed to mention is that, with all the nice things you get with WCF, at the expense of simplicity, also comes the fact that it's up to you now to create your queues, topics, subscriptions, etc., either through the portal or imperatively in code. So you can think of it as if you're using the MSMQ binding, for example, MSMQ, right, there's some initialization that you might want to do just to make sure that your messaging infrastructure is in place. The same thing applies to the WCF net messaging binding. Back to REST. Here's some of the things that you can do, right? So you can create and delete a queue or a topic. You can get a list of a queue or topic or all the queues and topics, subscriptions, and rules that are created. And obviously you can send and receive messages to a queue or topic using the different receive modes. What you can't do is you can't create subscriptions yet. You can't create rules yet. There's just some of the limitations based on getting as much reach as possible within a given timeline. But if the rate of innovation continues at the current rate, we've seen 2 drops since the initial release of brokered messaging already. So there's a very, very tight cadence with the Azure Service Bus team, and so I would expect to see some nice enhancements coming up, although nothing official there. So let's actually take a look at working with queues with the REST API. One of my favorite tools for working with REST is Fiddler. It's a free tool. If you aren't familiar with it, it's available for free. Just search for Fiddler. Basically what it does is it allows you to inspect HTTP and HTTPS traffic, as well as provide a nice test harness for working with HTTP. And one of the nice things about REST is that any user agent can automatically interact with your endpoints. And so what we'll do here is actually get a list of all the different queues that have been created, which we would expect to be 1. I've got some request headers here that are configured. The only thing I need to do now is actually get a hold of the wrap token. So I'm asking the access control service for that token, and go ahead and paste that in here. And now when I hit execute, I get a 200 OK back. And if I go ahead and transform this here, you'll see that I have a payload that includes the name of the queue and some of the settings on the queue, lock duration, etc. So pretty powerful. The next thing I might want to do actually is obviously write a message to the queue, right? So let's actually grab that here. In this case, that's going to be a post. And I'm just going to go ahead and change my URI here slightly, change my HTTP verb to post, and then we'll say hello world and hit execute. And in this case, I get a 201 created, which is what we would expect. And if I transform that, I don't expect to get anything back from a payload perspective. So let's actually wrap up here with reading the message off the queue, right? So we just wrote a message to the queue. Let's actually grab that. Set this here to delete, and we'll go ahead and execute. And sure enough, we are in good shape. I get back the actual message that I requested. So REST API, definitely very nice for interacting with queues and topics. A lot of nice capabilities, and you can actually specify both XML and JSON. So definitely something you want to take a look at, take advantage of for your REST scenarios. All right, so we've covered a ton. I know we're a little bit over. I appreciate everybody stepping with me. Want to make just a couple of announcements if you haven't already seen this. So new in the 1.6 SDK, the November SDK, is support for load balancing on Relay. So if you have a number of different Relay endpoints listening to ensure high availability, that's perfectly supported now. It basically provides a arbitrary kind of round robin approach for determining what endpoint to go to. So that was a much requested capability, as well as support for HTTP only brokered messaging in environments where outbound TCP 9354 may be problematic. There's now a mode that you can set to go ahead and force HTTP, which just expands the reach of brokered messaging even further. Some resources to make you aware of. I just published a pretty hefty article in Code Magazine on Azure Service Bus in the November-December issue. Definitely encourage you to take a look at that. It provides pretty much step-by-step walkthrough of much of what we saw here. Some good references on messaging patterns by Hoppy. There's a very good REST API reference that you'll really want to take a look at to understand how to interact with the service bus over REST. And definitely some great articles here by the MSDN team, as well as Clemens Vasquez on Service Bus that you definitely want to take advantage of. If Service Bus is new to you, for the few people, great article by Aaron Sconnard on Developer's Guide to Service Bus. It does not include the relay, the brokered messaging capabilities, but really a good introduction. And then definitely take a look at the Azure and the AppFabric properties on Microsoft. Last thing is we want to make an offer to anybody that attended today. If you're interested in understanding the roadmap for Microsoft's middleware strategy, reconciling where things are going in terms of BizTalk, Azure, AppFabric, how to make the right decisions today that are critical to your middleware strategy. We're having conversations with a number of customers, based on our success over the last couple of years and really bringing hybrid solutions to bear. We would be happy to spend anywhere from 90 minutes to a half day with you covering what the Microsoft application integration strategy looks like today, and our projections for tomorrow, and how to position yourself as well as possible. Also, if you're interested in looking at how to really take advantage of cloud and start to rationalize some of the workloads that make sense for moving to the cloud, we'd be happy to provide deep engagement with one of our key connected systems architects that are actually working with BizTalk, WCF, Workflow, Azure Service Bus, Windows Server AppFabric every day in the field today. So some of these technologies are newer than others. We've been working with these technologies now for several years, and are happy to make ourselves available to you. If you're interested in either a strategy briefing or deep insight into how to craft and design your own hybrid strategy, please drop Amy Nelson a note, and she'll be happy to coordinate that with you. With that, I want to thank you very much for your time. I hope this has been useful for you. I certainly have had a lot of fun, and I will be happy to hang out and answer any questions you might have.
Great. Thank you, Rick, for this awesome presentation. We did have quite a few questions come through. The first one, with the SQL action on a subscription, can I add a new property as opposed to setting, changing an existing property?
So I don't think that you can create a new property. I think you have to, I think you're limited to working with existing properties, but I'm not 100% sure on that. I'll have to actually take a look at that.
Great. Next question. What is the maximum size I can put on a queue?
So the maximum queue size supported today is 5 gigabytes versus 1. So pretty liberal there, I think, for most scenarios.
Great. And the next one. What is the difference between the WCF message class and the new brokered message class?
Yeah, good question. So that's definitely a topic that comes up a lot. And so, as I mentioned, the broker messaging class is kind of a departure from the WCF message class because of the need to provide these properties, which are really kind of interesting from a additional metadata and routing perspective. There's some publicly announced investments happening right now around integration services that are landing first in Windows Azure, and so if you think about the potential for being able to use these properties to route on without having to lock customers into WCF to take advantage of these capabilities, it actually makes a lot of sense. So the brokered message is all about providing these properties and this approach for kind of being this unit of communication for brokered messaging. It is fully 100% compatible with WCF via the net messaging binding. In fact, you can actually there's a good white paper that actually was just released that I should have actually included in the references that actually shows how to take advantage of properties within WCF. But it was kind of a needed separation to make sure that for developers that aren't using WCF, although WCF provides some pretty significant advantages from a productivity perspective and really kind of the core kind of messaging capabilities on the Microsoft platform. It actually makes a ton of sense to have those separated. So I hope that answers your question.
Great, thanks. Next one, can I change the default lock duration for a queue or topic?
You can, yeah. So you can do that. So when you go into the Azure Management Portal and you create the queue or the topic, you can accept the default of 60 seconds, or you can change that, and then you can also do so imperatively in code, using the .NET API specifically.
Great, and the last question I have here is, what is the difference between message sending, message receiver, and queue client?
Okay, yep, that's a good one. So if if you know that you're going to be using queues, and there's no reason to upgrade the topics, so to speak, you're just fine using the queue client. You definitely want to think about your scenarios to make sure you identify hey, this is actually really a topic scenario, not a queue scenario. And so the whole idea with message sender, message receiver is that it kind of insulates you from that change, such that if you do want to actually move from a queue to a topic, or you don't want to be bound to one or the other, you obviously have to make that initial decision in terms of what that backing store is. But the message sender, message receiver basically abstracts whether you're working with a queue client, topic client, or subscription client.
Awesome, thank you. If anyone else has any more questions, please feel free to type them in at this time. In the meantime, I'm going to click through a few polling questions, and we would greatly appreciate your feedback. The first question, was this content helpful for your business? Yes or no? Great. All right. The next question. Please rate the presentation content. Excellent, good, or poor. Thank you. And the last question I have is, would you like us to schedule a follow-up, yes or no? Great, thank you. It looks like I did have one last question come through, Rick. To follow up on the message receiver sender versus queue topic client, are there specific advantages to using the more granular queue topic clients?
It's really simplicity, quite frankly. In fact, kind of interesting is, the initial CTP actually had a chaining relationship between what's become the queue client and message sender receiver. And so queue client is definitely a simplification of that, right? So if you think about, I want to send and receive a message, it does not get simpler than, queue client instance.send versus receive. So they're functionally equivalent, but I think queue client is just a simpler API, quite frankly. So it's kind of the decision is, if you want to abstract yourself from that change, there's a little bit of a cost because message receiver is a little more there's more knobs, I guess, is the best way to put it. So definitely take a look at it. Experiment with the different APIs, and if you're not sure whether this is a queue or a topic implementation, consider using a message sender, message receiver. If you know for a fact that, hey, it's a queue and this meets all of the reasons why I want to use a queue, I'm not going to have different subscribers off the same message, then use the queue client.
All right, great, thank you. And if anyone else has any other further questions, you can go ahead and email me, amy.nelson@Neudesic, and I will forward them over to Rick. And we will be forwarding the link to view a recording of this webcast once it does become available. Again, thank you so much for everyone for joining us, and we look forward to seeing you on our next webcast. You are now free to disconnect. Thank you.